We're going to be talking about sharing logic and state between universal web and mobile apps today. And I am incredibly excited to be here. It was actually quite a hectic ride to get into India. I almost didn't make it because of some visa complications. I'm sure we've all experienced that at one point or another. And I'm going to tell you the full story about it in just a second. As they mentioned, my name is Mo. I am head of mobile at this company called Theodo. We've got a team in the UK, US, France, and Morocco. And we have over 150 mobile engineers doing React Native, Native, and Flutter. So you can find me on Twitter at Mo__Javad. You may also know us by another name, BAM, or BAM Labs. So our team's been in the React Native space since React Native really came out back in 2015. Libraries like React Native Image Resizer, or more recently Flashlight, which lets you measure performance of your mobile apps. So we're very passionate about mobile, let's just say. All right, let's get into the visa story, because I'm sure that's why you're all here. I actually I live in this city called Edinburgh in the UK, and it looks something like this, just so you have a visualization of what it's like. So when I wake up in the morning, I usually go on my phone and check my emails first thing. And last week on Tuesday, I got this email from Kiran, and he was asking me to fill in a Google form about some of the speaker details. So I didn't want to fill in a Google form on my phone, so I opened up my laptop, and I immediately got in my dock that I can open up my mail app on my laptop. So effectively, I was just able to open that up on the mail app and be where I was on my phone very seamlessly. And I went in and filled the form of the speaker details online. Cool. Now, the day's passing. I'm a bit stressed out about this visa situation because I still haven't heard back from the embassy. And I have this weird idea to take matters into my own hands. So I actually Google search where the consulate of India is in Edinburgh. Don't try this, it's a bad idea. I find the address because they're not answering my phone calls, they're not answering my emails, and I actually try to go and visit them in real life. Bad idea. And so when I open up my phone when I'm in my car, Google Maps already has the consulate of India selected. And it's already there without me needing to even think about it. So the state between my web search and my mobile search has already been synced without any effort from my end. It's seamless, it's needless for any effort, and that's what we're here to talk about today. It's this idea that in modern mobile and web applications, you want to be able to share state and the business logic across the board. That is what your users expect. We're going to look at practical ways where we can achieve that. Cool, so React Native is a big part of this story. When React Native came out in 2015, it was a way for you to write JavaScript code that would traditionally be running on the web, and then basically take that and put it into a mobile app. So we went from React, the principles that we knew in React about building UIs, and we pushed that over to native mobile applications. Some people had this idea. They said, well, we've already gone from web to mobile. Why don't we just go back? Why can't we use React Native on the web? And that's where Nicholas Gallagher came in and made React Native for Web, which was a compatibility layer between React Native and React DOM, so that we could support React Native apps on the web, right? So while the original vision by the React Native team was that you could learn once, write anywhere with React Native, people decided that they wanted to write once and run anywhere. Today we call these universal applications. They're apps from a single code base that you can run on web, mobile, and any other platforms for that matter. So wouldn't it be amazing if we could just write all of this in one centralized place and share as much as physically possible, as much as it makes sense, across web and mobile? So you might have an iOS app, an Android app, a web app, maybe some browser extension. I don't know why you do that, but you can. A Mac OS, TV, the options are endless, right? So a lot of people have been focusing on this space in recent years. You might have heard of Native Wind. It allows you to write Tailwind on web and mobile from the same code base, and it compiles down to the right target. Or Tamagui. Tamagui is a UI library that has a set of universal UI components. They run natively on web, and they run natively on mobile, and they respect the platform-specific implementation details. So UI styling and components on universal apps has been the primary focus, I'd say, for the past few years. People have been really looking into it. There's so many solutions. I'm sure you guys know Sanket. His team's been working on GlueStack as well, so this is the primary focus here. On the other side, people have been looking at universal navigation for a while as well. So libraries like Solito, libraries like Expo Router, they aim to bridge the gap between navigation on web and mobile. Inherently, navigation is actually quite different on web and mobile. You're dealing with URLs on web, so it's a flat hierarchy. But on mobile, you're dealing with stacks, you're dealing with tabs. It's just fundamentally different. So people have been looking at seeing how we can unify these two together. So we've got some incredibly smart people, far smarter than me, working on this problem, right? I've decided to settle for some of the boring parts, all right? And that's why you're all here today, to learn about the boring parts. So we're going to look at the less obvious parts. The questions that I'm interested in answering are the ones that people don't necessarily always think about, which is, how do you share things like business logic and app config? Things like the API layer and the adapters that come with it. And most importantly, things like the application state. So let's jump into the first one, business logic and app config. So what can we share from our business logic? What can we share from our app config? Let's start with the simplest one, which is the config. So you've got constants like API endpoints, like feature flags, maybe some of your theming, some of your localization. By and large, this is actually going to be all shared across the board. So if you define a constants object that's got some values that you're going to need on your web and your mobile applications, things like the app name, maybe some versioning, the base URL that you're going to call, some of the theming stuff, and feature flags, you can use these on your web applications and your mobile applications. But if you did happen to need to extend these, you can spread the common constants and add things like App Store description for the native app, or add some mobile analytics to the mobile version of your application. So that's constants, but specifically for your business logic, I'm going to be bold here and make a statement that you should actually share your web and mobile application. This is actually a necessity in today's day. Now, why is that? Well, you want to be able to reduce the rework that your team needs to do, firstly. You don't want to be writing the same logic twice on web and mobile, but on top of that as well, people expect feature parity. Show of hands, how many people have seen iOS and Android apps that are out of sync in terms of the features that are available? That is the majority, believe me. So, it's a really important step in assuring that, because you effectively write the logic in one place and you can use it across the board. So, we're going to come up with a very simple example here for some business logic. Let's say I'm building an e-commerce platform in the UK, and I want to handle some of the checkout logic. So I want to validate the postcode based off of the standard UK postcode schema. So I just have a regular expression there that we can test some string against. Simple function. This is all JavaScript, no React yet. And then I have a checkout function. All it does is it checks to make sure that we've got a valid postcode, and then subsequently, for now, it just console.logs if it's been successful or if it's been an unsuccessful attempt. Now let's reactify this. So I'm going to put it in a hook because everybody loves hooks, and we're going to call it use checkout, right? We're going to put all this logic in a custom hook. And so we've kept some state for the cart items, and then we've got the validate UK postcode function as it was. The checkout function is by and large unchanged, except we've actually set it so that it gets rid of all of the cart items after you've had a successful checkout. So this is the core business logic for my checkout application, right? And I've put it all inside of a centralized hook. And later on, we're going to be seeing how we can implement this on web and mobile and actually use this hook. Before we get there, let's talk about API layers and adapters. So you're going to be making most of your calls to the exact same backend, to the same services. There may be some discrepancies on different platforms. Maybe you need to keep some, maybe you need to request some additional data for iOS or Android or web, but by and large, it's going to be the same. Now, you can architect your app in a way where you actually put some of your network requests inside of a module, and then use those separately from the rest of your app. So all of your network calls and the transformation and the caching and all of that logic lives separate to the rest of your app. So a good way to look at this is if you need to refactor an API call inside of your application, how many different places do you need to touch? Do you need to change one file? Do you need to change 5, 10? And so you want to avoid that because you want to keep these as centralized as you physically can and make sure that you're not needing to have some sort of shotgun surgery problem. And so this diagram actually comes from Martin Fowler's article about modularizing React applications. If you create that fetcher layer that interacts with some of your domain logic, and it's completely separate from your state, it's completely separate from also your view logic, then you're going to be in a good place. And this is really essential for these universal applications because you want to keep these separate from the actual views and how they're being rendered on web and mobile. If you use a library like React Query, you can actually just put this all together. It does a lot of this for you as well. And you can create almost a package that has all of your React Query logic and how you want to transform it. All right, the meat of the talk, app state. So a lot of the state that lives on the client is going to be shared on web and mobile, right? Things like user history, interactions with the applications, you want to keep a track of that. That is client-side state that you're going to be keeping on web and mobile. Maybe some of your user session data is going to be kept on the client-side state, or maybe some local app customizations, right? You want to have some language preferences. You want to have display options, dark mode, light mode, whatever it may be, and some configurations. You want to actually share this state because you want users to have the same experiences with their state on web and mobile. It's what they come to expect, right? Let's take the same example of that shopping cart and actually turn it into a context here. So this is by and large the same logic, but what we've done is we've added some more validation logic here to say we don't want to allow for more than 5 items in a cart at any given time. So a user can only check out 5 items at max. They can delete an item, they can also check out, and it would reset the cart again. And we use this as a context. Now, we've created this set of state, right? The thing that we can do with this is we can actually package it up and then call this a state package or call it a domain package, whatever you may have, and then you can actually use this within your web app and you can use it within your native app, and using a tool like Turbo Repo or using a tool like NX means that this whole process is streamlined. You don't have to worry about conflicting types within your React runtimes. All of it's kind of done for you out of the box, right? And the power of this is not necessarily when you're just building a universal app. It gets even cooler when you're actually building separate, like if you have a brownfield project and you're building separate web and mobile applications, this approach actually works. So you can gradually start to implement this. You can start to take some of your state, put it in a package, and share it on web and mobile. And as your app grows and builds, you can keep all of that there, and it's going to be separate, and you don't need to write it twice. It works seamlessly. You have feature parity, all of the good stuff that we talked about. Cool? Let's look at a demo of this. Cool. So I've got a very basic app here. It's an app that has a search input working on web and mobile. This is actually a universal app, so it's going to be one code base, but this would work again if it was a web app and a mobile app that were completely separate from each other. And as I search for values here, I can search for places to visit in Bangalore. I'll have this save it in some state locally, right? Now, pay attention, this isn't synced right now between web and mobile. We're going to look at that in a bit. We're not there yet. We're just looking to share the logic, but not actually share the sessions and the state at once. So let's look at how we've structured this repo to begin with. This is more of the architectural side of it, practically speaking. So the folder structure that I've got is a classic Turbo Repo example. This is very similar to what you would get with the React Native Turbo Repo example. We've got a packages folder. It's got an app, a domain, and a UI. And then we've got separate apps for Expo and Next. So Expo is going to be running on the native side. Next is going to be running on the web side. So let's open up the domain folder and actually look at our index.ts. So this is what we've got. We've got a very basic hook defined here. So this hook is called useSearch. It's got a state which is history, which is an array of strings. And then it sets that value every single time you call this callback with a term, which is a string. And lastly, it returns to wherever this hook is called, is going to return the history, but also the add search history. Now let's look at our main home screen, which is the one that we see here. So we actually call this useSearch hook and get the history and add search history values. And then we basically, every single time that you press this button, we call the callback that we've defined to add an extra value to our search history. Cool? It's very simple here. So what we're going to do is we're actually going to add some logic here to clear clear all of the search history, because maybe you don't want to keep that, right? So let's call this clear search history. We'll make it another callback, and all we're going to do is we're going to set history to an empty array. And our dependency array is just going to be set history, right? We're going to return this. And so very easily in this screen, we can come in and just say, get me clear search history. And then I'll just define a button here. Clear. And what we're going to do is we're going to call an onPress. And whenever this button is pressed, we're going to actually just call this clear search history, right? There we go. All right. So because this is a universal app, changing it in what place has meant that I have actually modified it and added this feature on web and mobile. If it wasn't a universal app, you could still do this because you've put all of your domain logic, all of that hook logic, inside of a common hook that you can import on your web and mobile applications, right? So this is where this is actually really powerful, I think. It's in brownfield applications where you can start to incrementally implement it. So we're going to search something, again, Bangalore. When we go, there we go. It's there, shared there. Here, if I actually search something like hello, it'll be there. Again, these are separate right now. We're going to touch about how you can sync them as well later. And then the clear functionality works as well, right? Cool. So that's all good, right? We've shared the logic, but we're not actually sharing state yet. We're just at the first step. We're just sharing the logic. Now, a little while back, Alex, who's the creator of TRPC, tweeted this saying that useState and useEffects are code smells, which was an interesting statement to me, right? We all use useState and useEffect abundantly within our applications, right? And if you were here for Tejas' talk yesterday, it was kind of hinting at the same thing. Once you start to think about React Server components, a lot of your state will then not live there, so you won't have to use useEffects. You won't have to use useState, right? And so then I was like, well, how do you suggest actually avoiding useState and useEffect? And the response was that your state storage and computation should actually live in the backend. And this was actually where I initially got the idea for this talk, right? How do you keep all of this data in the backend? And then upon thinking about it a little bit further, we realized, well, this whole consulate of India search that I had earlier was this. All of this data was stored on the backend. The state was actually just on the backend, and I was ingesting it as the client application while it felt like it was all being kept in sync, right? So how do we actually practically implement that in a way that is performant, in a way that is easy, and doesn't add a lot of complications? You don't want to be managing this on the back end because it's just so much extra work for you, right? And that's where actually the power of the edge comes into play. Show of hands, how many people are familiar with edge computing? Okay, so for those of you who aren't, the idea with edge computing is that you bring compute closer to your users, and by doing so, you actually reduce the latency of your applications. So Cloudflare is a big player within the edge computing space. They have their edge computing platform called Workers. And what this basically means is that they've got servers scattered all around the world. They've got 300 plus points of presence. And what you can do is you can run JavaScript code at any point that's closest to your users, right? You create something like a serverless function. Think of them as Lambda, but just spread across the world without any regions. And they run instantly. There's no cold starts. And it actually is just perfect for this, right? You want to have simple JavaScript code that you can run at any point, and it's very close to your users, almost making it feel like that's happening on the client side. So in the past, where we were having the state live on the client for web, and we were having it live on the client for mobile, what we're going to do is we're going to actually just push it away and pass it to the cloud, and we're going to have it live on the edge, right? Let's see how we can actually do this. So to actually do this, there's a friend of mine from the Cloudflare Workers team, Samuel McLeod, and we spent some time building a very simple SDK called Worker Functions. So if you want to find it afterwards, it's just mojavad/worker functions. And the idea here is that we actually really liked TRPC, but we wanted to mimic this in a edge native way. So we created an SDK that lets you use Cloudflare Workers in the simplest way that we could envision it, right? We wanted you to be we wanted to have full type safety across the board, very similar to TRPC, so that when you define a function in a worker, when you have a function running on the edge, you can actually inherit all of the types on the front end. I'll show you what that looks like in a second. And it's just as simple as writing functions, because we don't want to complicate the state management too much. Even though we want to get a lot of gains from sharing the state between web and mobile, we don't want to make it too complicated. We don't want to make everyone write a whole bunch of backend code for it. And it doesn't have any boilerplate. So let's get started and see what this looks like. All right, so I'm going to start this demo with split screen, and I will separate them in a second, but I just want to show you how this works. So in the folder structure, what we've got is we've got a server folder, and we've also got our front-end code. So that server component is going to hold all of the logic that's going to be running on Cloudflare workers. And within the server folder, we've got an index.worker.ts file. So the worker functions SDK looks for any files that end with worker.ts and knows that that is going to be running on a Cloudflare worker. And so you can see all of the logic that's inside of this index.worker.ts is actually going to be running on the back end. But it's basically JavaScript code, right? It's very similar, and it mimics the code that we previously had. Add search history. Or above it, there's get search history. So this is all the same. The only difference here is that we're actually now starting to deal with databases on the edge. So we're going to be using Cloudflare's D1 database, which is an edge serverless database to actually store the user state within it. Cool? So I'm not going to go too much into this logic because it's irrelevant, but if you wanted to learn Cloudflare's database logic, they've got some great docs about it. But basically what I'm doing is, in the get search history function, I'm simply running a select and getting all of the results from our searches table. And then on the add search history, I'm basically inserting into the exact same table. Simple enough? Cool. And let's leave this for now. We're going to implement this in a second. And then on the left side, we've actually got our app. So this is client-side React code. What I do is I initialize a worker client and pass it in a URL. This is going to have to change in a second once we open up and run it on the dev client. And then subsequently, I basically have access to all of the functions that live on this side. So this worker is actually typed depending on what the values are here. And I'm going to show you how that is really, really helpful and maintains some level of continuity. So when we go to add search history, right now I'm binding the this, but then afterwards I'm actually saying that whenever someone calls this function, it needs to be with a string argument that's called term. But if I actually remove this, you can see that on the left-hand side in my client code, I've actually got a typing error because it's saying I'm no longer expecting this argument from you. So all of the typing is actually shared across the board. It makes you feel like you're working in the exact same workspace on the front-end side, but also on the edge. So let's go ahead and add that back in, and the typing error is gone, right? It's seamless. So let's save that and get it back to the initial state that it was. I'm going to comment out this code, and we're going to add it back again together in a second. But what we have, let's comment this out as well. What we're going to do is we're going to first initialize our Cloudflare instance. So we're going to run yarn dev worker, and this is going to initialize it on my local host and spin up the worker so that I can actually start interacting with it from my app. So once that runs, we're going to yarn start this. So I get a URL here. This is the localhost URL that it's running on, so we're going to replace this here and say that my worker function is going to be living there. Cool. And let's close the previous demos stuff that we had. So the first thing I'm going to do is actually I'm going to open up the Android simulator. Let's reload this. Might need to restart this. That's annoying. Cool. So this is now building for Android. We'll take a look and see what this app looks like. So it's very similar. We've got a search bar, and it's got a search history as well. So we're going to put in some values here. I'm going to say Bangalore. And we're going to also look for some food to eat here, so on and so forth. And as I do that, more and more is going to get added to this list in my history. Cool? Now let's actually open up the iOS app as well. So I'm going to open up the iOS simulator. Yes, so this is going to take just a second because it's going to install Expo Go. Let's see how long this takes. Cool. And you can see the state is actually synced. So the moment that I opened up my iOS app, we've actually got the state across the board, right? Now, what we're going to do is we're going to implement the clear functionality in one go across iOS and Android, right? So I've got some logic here. I'll uncomment it, which is creating a new function called clear search history. What does this do? It basically just runs some more SQL, deletes all of the rows from it, and truncates the table. And then afterwards, what I'm going to do is I'm going to call the get search history, which is a function that I actually defined above. So within worker functions, I can define I can call another worker function and basically chain them all together, and it's just working as if it was just pure JavaScript, right? And then I can call that and get all of the new histories once you've cleared, which would be an empty array. Let's save that, and that's going to be live updating. On the client side, I should now have access to this. So when I call my use callback, I actually see worker has this clear search history function, and it's returning a promise, which is search history item and an array, right? And I can set the history to that. So I've got this callback now. Now I'm just going to have a button here that actually calls this. So this button is going to now call the callback and going to clear the search history. And this should work, so let's go ahead and rerun. Cool, let's ignore the font errors. So I've got a button now that says clear history. And if I actually call it here, it clears the history. Now these aren't synced, but if I actually go in and reload the application, you can see that it's going to be synced across the two, right? So the next natural step that you're going to want to take is actually put this with WebSockets. Because if you have a WebSocket connection, what will happen is that these apps can all be listening and subscribing for events, and there'll be real-time syncing. So you could build possibly anything that you can imagine with that, right? It's really, the possibilities are really endless there. And it bodes well for creating apps like Notion, where you want live collaboration there, Google Docs, and so on and so forth, and it's all going to be kept in sync, right? So this is just a glimpse into what you can do with the edge if you move your state there. And again, once we're reaching into this era of RSCs, you're going to have to be thinking about this more and more. Where does your state live? How do you handle all of these questions? And I think this is a really cool step to take that question and put it into React Native. All right, so I'm going to finish up. I've been talking for very, very long. Thank you for bearing with me. Quick recap. Modern apps sync state endlessly between web and mobile. We've seen examples of this, right? You come to expect it. As a user, you want this, and you subconsciously have this expectation from your apps. Most of your app's config, the logic and the state should be shared. This is more of an imperative. It should be shared rather than it couldn't be shared. It can't be shared. Monorepo tools like NX, like TurboRepo can actually help streamline this process. They can make it seamless so that it's not extra cognitive load on you. And in the age of RSCs, you want to push as much data as you can to the server, right? You don't want to store this on a client. And sometimes the edge can be a really cool solution to avoid bogging down your backend with too much of this logic that you would keep on the client side. Thank you so much for listening. Really appreciate it. And feel free to stay in contact with me on Twitter or LinkedIn. Those QR codes should take you there. Thank you again. Appreciate it.